Hi friends, myself Rahul Kotkar. We are going to discuss here chapter of physics of standard 12th, rotational dynamics. So first thing, to understand the rotational dynamics, first we have to discuss about what is the dynamics. So the word dynamics comes from definitions mechanics. Okay, so mechanics is the branch of physics which deals with the study of object in motion. Means in case when the object is in motion, the study of such an object is done under the branch of physics called mechanics. Okay, so it's very simple. The mechanics is the branch of physics which deals with the study of object in motion. Okay, so this mechanic again having two sub branches. One is called statics and other is called kinetics. Okay, so in case of branch statics, so the static is the branch of physics which deals with the study of object which are in equilibrium, or you may call at the rest. Okay, means for the case the object which are in the rest, they are under the equilibrium conditions. What do you mean by equilibrium? If there are forces acting on the object, the number of forces acting on the objects are equal and opposite, they cancels each other. Okay, in short you may call it, suppose this is the object and on this object a number of forces are acting. Let this two forces are acting on the object. If these forces are equal and opposite, the resultant force acting on that body is equals to 0, then you said that the body is said to be in a equilibrium or at the rest. And study of such an object is held under the branch called statistics. Okay, next, that is the kinetics. Okay, what about the kinetics? So in case of kinetics, there are again two sub branches. One is called kinematics and other is called dynamics. So first we discuss about the kinematics. So what is the kinematics? Kinematics is the branch of physics or branch of mechanics which describes the motion of the object without their cause. Okay, means when an object performing some motion, it moving on a road, suppose with certain velocity, at that time we are not interested in the things why that object is moving with a speed 100 km per second. Okay, what are the reasons behind that? We are not interested there. We are just interested in study the displacement of that object, how much the speed, velocity, acceleration, like this. Okay, means we are studied this parts under the kinematics. Okay, in short you may got. Okay, what is the important thing? Kinematics is the branch of physics or mechanics which deals with the study of object or motion of the object without their cause. Okay, so means we are not interested there why that object get accelerated, why that object get stopped, okay, deaccelerated, why its velocity is constant, whatever it may be. We are not finding the reasons or we are not studying the reasons behind them. But in case of dynamics, dynamics is the branch of physics or mechanics which deals with the study of object in a motion. Okay, so when the objects in a motion, we are interested to study the reason behind them or cause of the motion. Okay, understood what I am saying? What is the dynamics? Dynamics is the branch of physics or mechanics which deals with the study of objects with its cause. Okay, means we are interested why the object is moving with 100 km per second, then how much the force is acting, which force is acting, okay, what is the pressure, means behind that what are the conditions so that the object is moving with some speed. So this is the dynamics. Okay, then next important thing in our chapter is to understood the particular concepts, say as to a rigid body. So what about the rigid body? Okay, in case of rigid body, the word rigid body says that, okay, if the object do not changes its dimension under the action of external unbalanced force. Okay, let's suppose that is, we consider this is the object. Okay, this object is made up of a number of small particles. This particles say as to like this is one particle, this is another particle. So as these particles are separated by a distance d, okay, say as to small d, they are separated by a distance. Under the action of unbalanced forces, means a number of forces acting on this body, even these two particles never get separated or never changes their particular distance between them, then we call it as a rigid body. Means that body is said to be rigid body. Means what? The distance between these two particular particles or atoms remains the same, constant, and such a forces are called such a particle, okay, or such a body is known as a rigid body. Means in short, what we can say, the body which do not changes its dimension, means what? Length, height, whatever it may be. Okay, so under the action of external unbalanced force. Okay, so such a body is said to be a rigid body. Okay, means the body which do not changes its dimension under the action of external unbalanced force. Shortly. Okay, so the combination of this rigid body and dynamics, okay, we have to focus. Means this chapter is also called rigid body dynamics. Okay, means we have to study the rigid body's dynamics. Means what? Dynamics means the study of motion with their cause. Okay, and for what? Rigid bodies. So most important thing, there is no existence of rigid body in the universe, but for practical purpose we imagine the body is the rigid. Okay, so next, the rotational dynamics. This particular chapter included in the syllabus is the combination of two particular main chapters or motions, that is a circular motion and rotational motion, as from the previous syllabus. Okay, so here what we can say, first we have to study 1.2, that is characteristics of circular motion. So what is the characteristics of circular motion? Before that we have to discuss what is the circular motion. Okay, so motion of the particle along the circumference of circle. It's simple. Motion of the particle along the circumference of circle, it's called circular motion. Okay, just I am representing here. Okay, the motion of the particle, if the particle performing circular path or moving along this circular path, then this motion is said to be circular motion. Okay, so the motion of the particle along the circumference of circle is said to be circular motion. Okay, so we have to study the characteristics of such a circular motion. Okay, so in case, first characteristics is what? Accelerated motion. So everyone know that accelerated motion means where there is the change in velocity. So just we discuss about the velocity of the particle which performing the circular motion. So in which the velocity is constituted of magnitude of and direction. Okay, means what? The velocity having, it is a vector quantity, and so the vector quantity having a two things, one is called magnitude and other is called direction. So in case of magnitude, magnitude means what? Speed of the velocity. Magnitude of velocity means what? That is the speed, and the speed remains constant. Listen again, velocity is the vector quantity, and this vector quantity, okay, having magnitude as well as direction. The magnitude of velocity means what? Speed, and in case of circular motion, the speed is remains constant, okay, which is called uniform circular motion. Okay, So speed remains constant, and this indicates here means what? The speed of the particular particle performing circular motion is remains constant, but there should be the change in direction continuously. Okay, means change in direction of the particle shows the change in velocity, and this change in velocity produces the acceleration, and that's why circular motion is the accelerated motion. Okay, just why the magnitude is constant and its direction going to be changing, that's we are representing here. Okay, so the magnitude of velocity is going to be constant. Okay, and why we call it like this? So in case of this, when a particle performing circular path, so the velocity is always tangential, okay, linear speed, which is known as a linear speed or linear velocity, and this linear speed is always tangential to the circle or circular path. So in that case, this is always tangent to the circular path, and this tangent is having equal length, means what? Magnitude is constant. Okay, if you look all these arrows, means what? That is a vector which represents the velocity of the particle, whose magnitude means whose length should be the same, but the direction is going to be changing at point to point. Here we observe at the upward direction, here to the left side, here to the down side, here to the right side. In this manner, what we can say, the direction is going to be changing continuously. That's why velocity changes, and as the velocity changes, the body is said to be in an accelerated motion. Okay, so next is your second characteristics is your periodic motion. So why it is said to be periodic? Because the the particle performing circular path again and again in a fixed interval of time, okay, which repeats its path, and so it is called periodic motion. Anyone have doubt? Okay, if you have doubt, you can ask me the questions in a comments. Okay, so the next point is your, that is kinematics of circular motion. Okay, again the word comes here, kinematics. We just studied about the kinematics. This is the, okay, there are two sub branches, kinematics and dynamics, which are generated from kinetics. Okay, so we have to study the kinematics of circular motion. Means what? Simply we have to study about the angular displacement, angular velocity, angular acceleration, etc., etc. Might be you may study the linear uh, displacement, linear velocity, linear acceleration also, no problem. Okay, but here we are about the circular path, and so we have to study the kinematics in terms of circular motion, that is a angular displacement, angular velocity and acceleration. Okay, so first I am going to explain in kinematics, that is the angular displacement. Okay, what about the angular displacement? Just a second. Okay, so in case of angular displacement, what is the angular displacement? It's simple. When a particle performing circular path, when a particle performing circular path, okay, along the circumference of circle, at that time when particle means the radius vector, okay, changes its position from one point to the other point, forms or makes certain angle with the center, such a particular angle is called as angular displacement. Okay, it's somewhat complicated, so I am explain it briefly and by a simple manner. Okay, so everyone know, first I am going to explain what is the position vector or radius vector. So in case of circular path or circular motion, okay, there is the term radius vector or position vector. So what is the radius vector or position vector? The vector which is drawn from the center of the circle to the position of a particle performing circular path. Okay, listen again what I am saying. When a particle performing circular motion or circular path, the vector drawn from the center of the circle to the position of the particle performing circular path or circular motion. Okay, this vector is called as radius vector or position vector. Okay, why it is called radius vector? Because it lies along the radius, or it present along the radius, as well as it indicates the position of the particle. Suppose the particle is present here, the vector drawn from the center of the circle to the position of the particle, so it indicates the position, and so it is also called as position vector. Okay, so again we start with the angular displacement. So what is that? That is simple one, the angle described by the radius or position vector when it moves from one position to the other position along the circumference of circle. Okay, when a particle moves from one position to the another position along the circumference of circle, the angle form is there called angular displacement. Okay, so again, in case of this angular displacement, in case of angular displacement, okay, we have to go through its magnitude. So what about the magnitude of angular displacement? So everyone know the arc of the circle. Okay, arc of the circle, it's simply the part along the circumference. Okay, so in that case, the angular displacement having magnitude, or it is given by a formula, arc length divided by radius. Okay, so arc length having value s and radius is your small r. Okay, as from this figure, if the particle is performing the anticlockwise motion, okay, everyone observe here. So in that case, we consider that when a particle moves from A to B, it having certain arc length, say as to s. Now someone have question in their mind. Okay, so here the particle is moving from A to B, which is observed to be a circular path or a somewhat curve. But why you should write there s as a displacement, that is a linear displacement? So the reason behind that, remember, in case of circular motion, we consider that the time tends to zero always. Means when a particle moves from one position to the other position, okay, along the circular path, so we consider that this time period is too much shorter, and as this time period is too much shorter, and therefore this is nothing but a smaller linear displacement, and that's why I am representing here linear displacement as a s. Okay, so simple, arc divided by radius, and that should gives us the formula s is equals to r into theta. Okay, then this gives us the magnitude of linear displacement. Then what about the direction? It's simple. To represent the direction, we just talk here. Okay, to represent the direction, we just discuss here, that is the, as a angular displacement is the vector quantity. Okay, and so as it is a vector quantity, so it is a axial vector. Why it is called as a axial vector? याला axial vector का म्हणायचं? Simple. Let me consider that this is the, okay, this is the plane of rotation. Okay, means we just observe it horizontally. This is a plane of rotation, and as a plane of rotation is observed like this, so this vector of linear displacement is always directed perpendicular to the plane of rotation. Okay, Remember everyone, the axial vectors means what? That is perpendicular to the plane of rotation along the axis. The vector having a direction along the axis of rotation. So in this case, what we call it is a axial vector whose direction is given by right hand thumb rule. Okay, we discussed this right hand thumb rule in a standard 11th. So laterally I am going to explain this also. Okay, then next is your angular velocity omega. Okay, so what is the next kinematical physical quantity? That is a angular velocity. So angular velocity, that is called omega. Okay, so everyone know the simple definition of angular velocity, that is the rate of change of angular displacement. Okay, means there is the as displacement, angular displacement of the particle is going to be changed, there should be the change in angular velocity, the angular velocity is produced there. Okay, understood? Means if there is the change in angular displacement with respect to time, we say that the body is having angular velocity. Okay, so again you observe in many more cases, somewhere it should be written as a delta like this, using a triangle, either this one, or somewhere it is written as a d. So what is the difference in this all? So it's very simple. When we are going to find, I am explaining in terms of the explain this term in terms of the linear velocity. Okay, and better one to understood using the linear velocity, and it is same in case of average angular velocity also. So if suppose we consider that from a point 1, when a body moves to the point 2, or from A to B when a body moves, okay, so it will having a certain different linear speeds. Okay, and these linear speeds are calculated between these 2 points. It's called average value of speed. Okay, means what is the average when it reaches from this one position to the position 2? What is the average value of velocity? That is given by this delta using a triangle. Okay, or you may write like this delta. Okay, means to indicate this one we using a delta. Okay, and in case value at any instant after 10 minutes, what is the speed of the car? That can be given by instantaneous value of velocity. Okay, we just make a simply convert into the angular values. Okay, means what? When a particle performing circular path, okay, while performing the circular path, the average value of angular velocity means what? When it starts from this particular point to after a 10 seconds, 20 seconds, etc. Okay, but in case instantaneous value means the value of angular velocity at a 3 seconds, at a 5 seconds, that is called instantaneous value. And you may observe here, okay, when you take a limit of the average value of angular velocity, okay, average value of angular velocity, okay, the limit tends to 0, means what? For a very shorter time, instantaneous, that is what? At that instant, त्या क्षणाला, त्या वेळेस असणारी angular velocity, and that is given by here d theta by dt, which is a standard formula. Okay, so then we go through the next point. Here I am representing the relation between v omega. Okay, so to represent the relation between v and omega, okay, let's see simply to represent the relation between v and omega. Here we have to use the simple concept as we studied the formula S is equals to r into theta as per the definition of angle or angular displacement, that is theta is equals to S divided by r. Okay, so friends, simple, as you differentiate this relation with respect to t, Okay, that you observe in this step, that is ds divided by dt. Okay, as you differentiate, it's ds divided by dt. Here also, okay, according to the product rule, you may take first constant, second derivative, then add, okay, second constant derivative of first. Okay, but it's simple. R is constant because it is a radius of circular path, and so there is no need to take the derivative of r. So take a r constant and d theta divided by dt. So in that case, what you observe, as you take the derivatives of this term, that is ds divided by dt, is nothing but rate of change of displacement or linear displacement per unit time is the linear velocity v, while r is constant, and rate of change of angular displacement, that is d theta by dt, it is your omega. Okay, so in this manner, what we can say, this is the relation between v and omega. Okay, this is a famous relation in the previous syllabus. Okay, so after that, this will gives us the magnitude of velocity. Okay, this gives us the magnitude of linear velocity. And remember friends, this velocity or magnitude of velocity is always tangential to the circular path, and so it is known as a, or called as a, tangential velocity also. Okay, so what is its vector form? So its vector form is a simple one, as you observe here. Okay, v is equals to omega cross r. This is a vector form of the tangential velocity. Okay, so everyone happy with this? Now you have to remember one more noteworthy point, and that noteworthy point, okay, is what? That is the direction of theta, omega, alpha, means what? Angular displacement, angular velocity, angular acceleration are perpendicular to the plane of rotation. Okay, means what? What we can say, when a body is revolving in a circular path, okay, so at that time the direction of theta, omega, alpha are always perpendicular to the plane of rotation. Either it is in the upward plane, or upward direction, or in a downward direction, and that direction is may upward or downward, that can be given by right hand thumb rule, and we already discussed this right hand thumb rule in a standard 11th. Okay, so I'm just revise this one shortly, so everyone know what is the right hand thumb rule. So when an axis of rotation is held in your right hand in such a way that the fingers are curled round the axis of rotation and thumb is outstretched, then the curl fingers shows the direction of rotation of particles, and the stretched thumb gives the direction of theta, omega or alpha. If the particle is performing anticlockwise motion, means as you say thumbs up. Okay, in case of thumbs up, when the particle is performing anticlockwise motion, okay, and here the direction is in the upward direction for theta, omega, alpha, okay, that is in a positive direction. But when thumbs down, in that case, okay, the direction of particle is what? In a clockwise direction, and what you say, that is the downward, that is theta, omega, alpha are having direction in the downward direction, that is in a along negative side. Okay, so in this manner, what we can say, we can obtain the directions of all these theta, omega as well as alpha, where alpha is the angular acceleration. Okay, so friends, give the comments, okay, if you have any doubt for this introduction lecture. In the next section or in the next lecture, we are going to study the difference between the uniform circular motion and non-uniform circular motion, okay, which is very important aspect, the standard 12 as well as NEET and JEE also. Thanks for watching the video.